Good morning, you two, and welcome to Wednesday, the 13th of January 2021's maths lessons. Today, we are going to be learning how to use a part-whole diagram that has missing parts. Our steps to the stars are: remember the difference between a part and a whole, understand what a part-whole model shows, and find the missing parts to the part-whole model. Okay, previously in the week we've looked at partitioning and we've also looked at the part-whole model, but today we're going to be looking at that same model but with different parts. Okie dokie. Have a look at this part-whole model for me. What can you tell me about it? Pause the video now and have a little think. We can see that the whole at the top, that equals 23. We know this because there are two 10s, 10, 20, and three 1s, 23. We can see that one of the parts, the one at the bottom, is 12. There's one 10, 10, and two 1s, 12. But the other part is missing. How are we going to work this out? Well, there's a number of ways we can do it. The first way we can do it is by subtracting one of the parts that we've got at the bottom by the whole, from the whole. So that's 23, take away 12, and it gives us 11. So that could suggest that 11 is our missing part. To check that, we could do the inverse operation and add 11 and 12 together to give us 23. Another way that we can do this, if I just make my screen big, is to have a look at the deans that have been used in the whole and one of those parts. So I know that down here I've already used 110. Okay, that one's just here. And I know that two 1s have already been used, so I can cross those out. What's left in my whole is 1 10 and 1 1. And that we know is 11. That would suggest to me that those that are left over that haven't been used in one of those parts go in the other part, okay? So let's have another look. 25 is our whole. How do we find out the missing part? Pause the video now and have a go yourself. So, like I said before, we can use our addition and subtraction knowledge, or we can remember our learning from the other day and do 10 less. We know that 10 less than 25 is 15, okay, and that would suggest to me that 15 might go in here. Now, if we're not sure and we want to check our number knowledge, we can use the column method to do that. So what I would do then is I'd do a bit of adding. I would have my two parts that I think equal 25 and I'd put them in a column addition method. So 15, I think it might be in there, add 10. Sorry, my numbers are so big here too. It's very tricky to draw on a computer. So 5 add 0, we know that that's 5. And two 10s together, we know that that's 25. Whoops. Oh, look at that mess. We know that that's 25. Let me cross it out and write it by the side. Here we go. So that to me, apart from the mess there, that to me suggests that this part-whole model is correct because all of the numbers that I've used in my two parts of my whole show up in my column method. Okay, let's move on. Now let's have a look at this one. This one's a little bit tricky because the numbers are, we can't really use, well, we can use our 10 less, but it's a bit tricky for us to count on quickly 10 less on this one. So let's have a look. 35 is our whole in the top and one of our parts is 11. We can do what we did before and use the column method to help us work this out. So let's have a look. If we have 35 there, and when I say column method subtraction, this is just an easier way for us to set it out. Okay, so I'm putting 35 at the top because that's my whole. And I'm going to take, oops, I'm going to take away one of those parts that I've got here. 11. So 35 take away 11, underline it. So 5 take away 1, we know that that's 4. And this 3 here represents 30, 30, and this one represents 10. So 30 take away 10 is 20. Or if we're not sure about that, we can do 3 take away 1, but we must remember that this is a 10. So we wouldn't call it 2 and a 4, we would call it 24. So that suggests to me that this might be 24. Now, I feel like I need to check this. I can check this with the inverse column method. I'm going to do it over on this side. Let me just move that out of the way. I'm going to do it over on this side. The way I can check this is by adding my 2 parts together. So the 2 parts that I think are correct are 24 and 11. Put my big number on the top, 24, and then I'm going to add 11. And 11. So 4 add 1, we know that really simply is 5. Oh, a very big 5. And 2 add 1, like I said before, it's not really 2. We know that this is our tens column, and we know that this represents 20. 20 add 10 is 35. Now, both of these column methods have all of the numbers that we've used in our part-whole diagram, so that suggests to me that 24 is correct in here.